In note 6.7, example 3, we're given some characteristics about a particular Ferris wheel, and we're asked to write an equation to model the height of a rider on the Ferris wheel as a function of time. So let's look at the information that we're given. We're told that the Ferris wheel has a radius of 20 feet. So I'm going to draw that on my Ferris wheel. So this is 20 feet. And this is 20 feet. Then we are told you complete 3 revolutions in 1 minute. So this has to do with the period, which we'll work on later. And you get on the Ferris wheel at the lowest point. This is a more normal Ferris wheel, which is 4 feet off the ground. So I'm going to draw that in on the diagram that distance is 4 feet. And now we want to start figuring out the characteristics for this Ferris wheel. So here I'm going to be prepared to make a little sketch. And let's see what we know about this Ferris wheel. Since the radius is 20 feet, we know the amplitude is 20 feet because that's the radius. So we know that A for our equation, little a, is 20. All right, we're also told that you complete 3 full revolutions in 1 minute. So the period is how long it takes to complete 1 full revolution, and we're told we have 3 revolutions per minute, which is 60 seconds. So the period is going to be 60 seconds per 3 revolutions, which is 20 seconds per revolution. So that's our period is 20 seconds. And for our equation, we really want to know the value for b. So 2 pi, which is the period for the parent function of sine or cosine, divided by b is going to be equal to 20. And we'll solve this for b. So I'll multiply both sides of the equation by b. So 2 pi equals 20b. I'll divide both sides by 20 to isolate b. So b is going to be pi over 10. So we'll use that in our equation. The other thing that we like to know for this function is the vertical shift, and we can figure that out. So since we know that we're 4 feet off the ground plus 20 feet, that's going to be where our midline is. So our midline here is going to be at 24 feet. The minimum height is 4 feet, and the maximum height is 24 feet plus the radius of 20, so that'll be 44 feet. And so if we're thinking about sketching this graph, I would go ahead and I would draw in a horizontal line for the maximum value, which is at 44. This is the height, and this is time in seconds. We know the midline is at 24 feet. So I'll draw that in at 24. And the minimum points are going to be at the bottom of the wheel, which will be at 4 feet. Okay, so from this, we know that the midline is at 24 feet. So that means that D is going to be 24, right? We're up 4 feet off the ground plus the radius. So we have a vertical shift up of 24. So we know A, B, and D. And now we want to write an equation for either sine or cosine. We'll see which one's easier. Okay, so we're told that when t equals 0, we get on at the bottom of the wheel. So when t equals 0, h equals 4. That's where we get on the wheel. So I'm going to put some points on my graph. Since the period was 20 seconds, I'm going to put up here that key points are every quarter period. So that'll be 20 over 4, which is 5 seconds. So when putting the scale on my x-axis, I would count by 5. So 5, 10, 15, 20. And we know that when t is 0, we are at 4 feet. So that's where we get on. And then every 5 seconds, we're going to hit a new key point. So at 5, we'll be at the midline, which is 24. When t is 10, we'll be at a maximum, which is 44. When t is 15, we'll be back at the midline. And when t is 20, we'll be back at the bottom. So if we were to sketch this graph, it looks like that. And for this function, I think it's easier to write a cosine equation because we have a minimum point when t equals 0. So I'll write that down. So we're going to use cosine since start at a minimum, which means there's no horizontal shift. But this is reflected in the x-axis. So now we're ready to write the equation for cosine. So we'll have h equals, our a value is 20. In this case, we want negative 20. So negative 20 cosine. B is pi over 10, and we don't have a horizontal shift, so we can just write pi over 10 times t. And D, our vertical shift, is 24. So we'll have plus 24. That is the equation that models the motion on this, or the height of an individual on this Ferris wheel. And down here we're asked, now see if you can write a second equation to model the height. If your initial equation is cosine, write a sine and vice versa. So we wrote a cosine, so let's write a sine. So in choosing a sine function, pick a point where the graph crosses through the axis of oscillation. I'm going to choose the point 524. So that point should normally be at the axis of oscillation. So our function is shifted right 5 units. So if I'm writing a sine equation, this is shifted right 5 units, but it is not reflected. So we'll have a positive sine function. And I know this is not reflected because my graph is rising as I go through that point that I chose going through the midline. So now we're ready to write the sine equation. So we'll have h is equal to positive 20, the amplitude, times the sine of b is still pi over 10. And now I'm going to do t minus 5, and I'm going to factor out the b value. Otherwise, I won't have the proper shift. And then I'll add the d value plus 24. And if we want, we can distribute the pi over 10. So we can have pi over 10t minus 5 pi over 10, which will be pi over 2 plus 24.